So in this video, I want to talk about some of the sources of errors that show up sometimes in experiments to help you guys to understand the sources of limitations and how to address them in future experiments that you design. First of all, bias. Bias is intentional or unintentional experimental preconception. Or basically, this is ideas that either the experimenter or the researcher or even the participants or have about the experiment that's being done, which may lead to a specific pattern in the data because it invalidate the results. So for example, I think that this will work better than that. And then that's what ends up happening because inadvertently you acted different and made the expectation you had actually occur. To give an example of this, the researcher thinks the medicine that he created will work better than the medicine that already exists. And this bias that he has makes that show that he notices symptoms more often in the people who have the old medicine than the people who have the new medicine. And that in itself biases the results of the experiment. So a lot of steps are taken in experiments to reduce bias. We talked about the placebo as an example of that and the double-blind experiments to reduce that bias. Another kind of thing that causes problems in experiments is design error. Sometimes limitations exist inherently to the experiment because of the design of the experiment had a problem in it. Throughout the year, as you do experiments in class, I'm going to challenge you to find problems with the way you did the experiment. In other words, can you say the results were, as they were, truly representative of the real thing? Or is there something about the way you did this that is actually what caused the result? A lot of times the experiments that we do in class don't work, but not because the science behind it is wrong. Maybe it's something that you did, something that is in your design that was wrong. Maybe a step that you missed, something like that. So it's important to consider that. Also, sometimes it's just tool error or instrumental error. Let's say, for example, what you're using to make the measurement might not be completely reliable, precise, or valid. Sometimes say, for example, I am using a machine, and in the first time I use it, it gives me a number, but the second time I use it, it gives me another. So if the scale that I'm using is not reliable, that's going to cause an instrumental error in my experiment. That's going to bias my results as well. Sometimes it's also human error. The design was fine, the instrument was fine, but I read the number wrong, or I put it wrong on the machine, or I did something, or I forgot something that I was supposed to do. And that's very often. Another source of error is what we call attrition. And this is very common in research like medical research or psychological research, where you start the experiment with a lot of people, but by the time you're done, a lot of these people moved away or they gave up on the study, and then what you end up with is a subset of those people who are not the people you started with. So you no longer have the true random sample that you created at the beginning. Now you have something. But if there's something peculiar about the people who left, that might bias the results, because now you introduced a new variable to the results. So that's a problem. Another thing that's a problem, we talked about sampling, is representation errors. Because sometimes you create a sample that doesn't really represent the population properly or what you're trying to study. And then you also have bias because of that. And then sometimes, stuff happens. Sometimes for no particular reason it went wrong that time. We call these random or chance events. In statistics, it's said that no matter how unlikely an event is, if you try enough times, it probably will happen. As long as there's a chance of it happening. If the chance is not zero, with enough trials, it will happen. It's just called the law of large numbers. That means that once upon a time, you do something that's supposed to work, it won't work just because randomly that one time was the one time that the problem occurred. So chance events sometimes will screw up experiments as well. And these will cause errors, which might make you accept your hypothesis when it shouldn't be accepted, or it might make you deny your hypothesis when it should have been accepted, which are called type 1 and type 2 errors. And these sources of errors are very important to be aware of when you're doing experiments because these limitations have to be addressed as you develop better and better experiments with time.